My name is Robert Pickering. Today I want to tell you about the automated guitar pickup winder that I made for my senior project, EET480 for Old Dominion University. The professor is John Hackworth. Today's date is April 10th, 2010. As a proof of concept, right here is a pickup that I made with the automated guitar pickup winder. It's made with 6,000 turns of 42 gauge wire. It's got a ceramic magnet on the back of it. The pull pieces are made out of just regular machine screws. As you can see, it makes a fairly decent sound compared with the other pickups. That's the pickup that I made. Here's one of the stock pickups. Here's the other stock pickup. And back to the one that I made again. If you'll follow me downstairs to the garage, I'll show you the automated guitar pickup winder in action.
Okay, you want to look at it?
This here is the automated guitar pickup winder. Right here you have the brains of the unit. Over here is the stepper motor that controls the winding with the bobbin. This stepper motor here controls the traverse, pulling the magnet wire back and forth across the bobbin. Here you have two end stops where the traverse it'll actuate this push button. It'll stop, change directions, and go the other direction. Actuate this button. It'll stop and go back and forth. And what that does is it makes it so that the wire doesn't go off the end of the bobbin in either direction. And here, right here, is the holder for the magnet wire. Over here is the control of the whole system. Right here you have the LCD that asks the user how many numbers of turns you would like the bobbin to have, and down at the bottom it displays how many turns are left. This control here controls the speed. This control here controls the contrast of the LCD. This right here is the keypad where the user inputs the number of turns that they would like to have. So as a demonstration, this bobbin over here already has 200 turns of wire on it. Let's put another 100 turns on it. So I'll enter 1, 0, 0. This button here starts and pauses. This button here resets. So we've entered 100, and now we'll tell it to go. And as you can see, it's starting to turn. And if we come back over here, we can watch the speed control. And over here you can see that the speed is increasing. And now we've reached top speed for the system. You can see also over here that the traverse is slowly moving in this direction. It's going to get to the end over here. If you come back over here to the LCD, you'll see that it's counting down, telling us that we have approximately 50 turns left. Let's try pausing it. That was the pause. It says that we have 46 turns left. Let's tell it to go again, and now we'll hit the reset button, and it goes to 0. And over here at the very top we have a master reset for the whole system, so we'll just clear it. Now I'll turn it off, and I'll show you the insides of it. Here's the power supply for the whole system. It's powered by just a regular computer ATX power supply. I'm using the 5 volts here to drive the stepper motors, and the 12 volt line here I regulate down to another 5 volts in order to drive the microprocessor and the direction control flip-flops. If we go over here to the board, you can see this is the back of the LCD display. It comes as a whole unit. Over here again you have the dimmer control and the speed control, the back of the keypad. Over here, this is the heart of the whole system. It's a PIC 16F887 microprocessor. You can see it's there. The other device that's used to control the traverse of the mechanism is a 74 LS74 D flip-flop. It's using the asynchronous inputs to set and reset it, and that input goes into the microprocessor to change directions. Okay, in here you can see these are the MOSFETs that drive the stepper motors. They are all IRF530 MOSFETs. Each of these here are 1N4004 diodes that are protection for the MOSFETs as they're controlling the motors. Over here is the 5 volt regulator that I mentioned, changing the 12 volts down to 5 volts for the 74 LS74 and the PIC 16F887. Here's the 20 megahertz resonator. Here is a series of 10K resistors that are used in conjunction with the keypad as pull-down resistors. And over here, these are used with the dimmer and the speed control circuits. That concludes the presentation of the automated guitar pickup winder for EET480. Thank you very much.